Okay, so we are in section 2, defining the atom. Is everybody ready? So you turn your page from your notes that we just got finished doing, and now we're going to the next section.
Use it, Science Notebook 2, Defining the Atom, Chemistry for You. If you have ever accidentally bitten into a peach pit, you know that your teeth pass easily through the fruit, but cannot dent the hard pit. Similarly, many particles that pass through the outer parts of an atom are deflected by the dense center of the atom. Review vocabulary. Model. A visual, verbal, and/or mathematical explanation of data collected from many experiments. New vocabulary. Atom, cathode ray, electron, nucleus, proton, neutron. Main idea. An atom is made of a nucleus containing protons and neutrons. Electrons move around the nucleus. Essential questions. What is an atom? How can the subatomic particles be distinguished in terms of relative charge and mass? Where are the locations of the subatomic particles within the structure of the atom? The atom. Many experiments since Dalton's time have proven that atoms do exist. So what exactly is the definition of an atom? To answer this question, consider a gold ring. Suppose you decide to grind the ring down into a pile of gold dust. Each fragment of gold dust still retains all of the properties of gold. If it were possible, which it is not without special equipment, you could continue to divide the gold dust particles into still smaller particles. Eventually, you would encounter a particle that could not be divided any further and still retain the properties of gold. This smallest particle of an element that retains the properties of the element is called an atom. To get an idea of its size, consider the population of the world, which was about 6.5 times 10 to the 9th power in 2006. By comparison, a typical solid copper penny contains 2.9 times 10 to the 22nd power atoms, almost 5 trillion times the world population. The diameter of a single copper atom is 1.28 times 10 to the negative 10th power meters. Placing 6.5 times 10 to the 9th power copper atoms side by side would result in a line of copper atoms less than 1 meter long. Figure 4 illustrates another way to visualize the size of an atom. Imagine that you increase the size of an atom to be as big.
All right, so we're having a lockdown, so we're going to have to do this again.